Welcome to our Isaac Sim Robotics Office Hours. We are so happy to have you join us today. As you can see, we have some great guests, including someone who's got a green camera right now. We'll fix that in a second. We are very excited, though. I'm going to cover all the news at the end of the live stream because we want to make sure all the developers have time to showcase what we're going to be talking about today, which is NuRec and Isaac Sim. We're going to be covering how NuRec workflows pair with high-fidelity simulation to speed up experimentation, validate ideas, and streamline end-to-end robotics development. It's going to be a totally jam-packed hour, so buckle up. We want to make sure all your questions are answered as well, so please use that chat box to ask your questions. Let us know if you're working on a related project, have any questions on where to find something regarding Isaac Sim. This is a live stream to ask those type of questions. If you have questions unrelated to Isaac Sim, probably not the best place to ask your questions live, but we'll just skip over them. Best place to go for that is on the Discord server, talk with other users or our forums. Isaac Lab, all support goes to the GitHub. So anyway, really excited. I have a fantastic host here, Rishab. Rishab, how you doing?
Hey, Edmar, I'm doing good. I'm very excited for the office hours today. I think we have an exciting topic to cover, and we've got an all-star team with us today to go through each of the aspects. So I'm going to give the stage to all of the guys here, Harel, Samir, Vihan, the quick intros maybe of you guys, and then we can actually jump right into the meat of the session as well.
That sounds perfect. Okay, I'll hang out and help out in the chat. Have a great time, everybody. So, Weihan, would you like to start with the intros, Weihan?
Yeah, sure. So my name is Weihan Wang. I'm the software engineer at NVIDIA. So currently I'm focused on working on the Real-to-Sim project. So collaborate with our NIE research team and our colleague Samir, Harel, and Dee. Yeah, that's it.
Thank you. Samir, you can go next.
Yeah. Hi, everyone. My name is Samir, and I'm also working with Vehan and Dee on the Real-to-Sim projects, and I'm mostly working on the pipeline and the infrastructure side, as well as doing some testing of the navigation policies using these NuRec assets.
Thank you. I think we had D earlier. We might be having problems with his camera. I'm not sure. D, can you unmute and maybe give a quick intro of yourself too?
Yeah. Does this work?
Oh, I think unfortunately there's some issue with your camera.
For some reason, I'm able to see myself.
Oh wow!
Maybe
you're NVIDIA over here.
You know now, DD. So let's do the intro yourself on voice, so we can all know who you are first, and then when the others introduce themselves, I would exit StreamYard and then come back in, and that might fix it.
Okay. Yeah, I'll do that. So hi everyone, this is Dee. I'm the engineering manager for Isaac mapping team. We are the team that building neural reconstruction engine for robotics and targeting essentially enabling robotics market. There are also a bunch of other technology we build, including CUDA-ized visual global localization, CUDA-ized structure from motion pipelines. So nice to see everyone, and I'll try to fix this camera issue. Thanks.
Thank you. And I think lastly, Harel, you can give a quick intro, and I know you're the one who's going to kickstart the session itself in terms of getting started with 3D reconstruction, bringing assets in, and all the cool stuff there. So up to you.
Awesome. Yeah, thank you. So hi, everyone. My name is Harel Omer. I'm the product manager for NuRec for Robotics, basically describing the real-to-sim technologies that we use for robotics. And let's kick off with some slides that we've prepared with all of the awesome work that the team has worked on in the past, basically 2 years. And what exactly we're going to do. So what we're going to cover today, we're going to do a short introduction about reconstruction in general, why this is important, what we want to achieve. And then we're going to talk about sim reconstruction with 3D GUT specifically. Why it is important, how is it different from 3D GS. Then we're going to cover asset loading into how we take the 3D GUT environment, loading it into Isaac Sim, and doing mixed rendering with synthetic assets. And lastly, we're going to cover how this environment is actually used for model fine-tuning. using those assets. So covering how we're actually using the real-to-sim assets inside a full end-to-end model. Okay, let's kick things up to start with. First of all, why? Why do we need that? So we're kind of addressing the two major problems in robotic development. On one side, we know that physical testing is expensive and dangerous, right? A lot of things can happen. The more complicated the platform, the issues become more severe. Now, that's on one hand. On the other hand, we know that real-world data capturing, so if we're talking about model training that requires trajectories, so getting those trajectories through real-world data is costly to capture. And how we're actually addressing those two issues. So in order to address those two issues, NVIDIA has the open robotic development platform across the three computers. So when we're talking about the three different computers, we're talking about the RTX Pro server that is used for simulation and synthetic data generation. And then we have the AGX, which is actually the onboard computer running the stack, and the DGX, the training computer. And we have in this session, and what we're targeting is around the simulation and synthetic data generation. And how this is being done, that's being done through Isaac Sim and Isaac Lab platforms. So we have Isaac Lab that is used more for imitation learning and reinforcement learning. And then we have Isaac Sim that is very useful and powerful for synthetic data generation and software in the loop testing. Now, the question is, what's the input to Isaac Sim and Isaac Lab? So the idea is to take 3D assets already reconstructed, tele-op data and real-world data, and injecting them in order to build this simulation environments. And then we have the full policy of the different robotic stacks. And in particular, in this talk, and with what we're doing with reconstruction, we are actually on the world of taking the real-world data and converting that into a sim environment. Now, that pretty much describes the entire NuRec product family, which is wide. It comes from from research all the way to different tools, libraries, and full products around Radiance field, physical Gaussians, meshing algorithms, etc. And in particular, in this office hours, we would like to discuss the 3D GUT technology and how exactly that's being useful as part of the environment creation. Okay, let's go back a little bit to the world of Radiance fields. The original goal have always been to have a novel view synthesis. So we capture the environment from a sensor in a certain trajectory, okay, and then we want to render the environment from a different angle. Why? Because we want to get more data. We want to do closed loop testing. So we want the robot that captured the environment in one trajectory will be able to render it while he's performing another trajectory. And we're all familiar with the original NeRF. That was pretty much the beginning of that. We had a very good novel view quality, but obviously the training and the rendering was pretty slow. Then the entire world caught up with 3D Gaussians planning, which have this explicit sim representation with Gaussians. It's fast, it's great, but it still had some potential issues. And then very recently, we came up, NVIDIA published the 3D GUT, the undescended transforms, which allows ray tracing. And why that's important? Because it helps us solve the rolling shutter with refraction and secondary rays. And then obviously it allows like fast training and fast rendering compared to 3D Gaussian ray tracing that we had before. And we're supporting distorted and nonlinear camera models, which means you can actually capture the environment with something like a fisheye camera, but then rendering it from a whole different sensor. Now, in this specific example, that's a trajectory in while performing some sort of curvature. So while with 3D GS, because of the lack of support of rolling shutter, you see that this novel use synthesis becomes blur. With the 3D GUT, it performs very well. And the 3D GUT research code is open source. Everyone are welcome to explore that. I think that's very interesting and important. Now, we've also published a technical blog, and we're able to render 3D GUT as it's inside of Isaac Sim. In particular, we've published a tutorial of how you can basically capture the environment using any type of camera sensor. You can do that with your iPhone, and then through a set of pretty simple method, you can take that environment, run a 3D GUT. Before that, you need to have, of course, a call map, and then later on, you can render it into Isaac Sim that we will discuss. We also added that support inside of the Isaac Sim documentation for you to review. Lastly, one other thing that I would like to mention is the addition of generative models in order to improve the scene. So we've also published the DFix. You can look at the model at Hugging Face. You can download that and use it for yourself. So that DFix has two different models. It has an offline mode and an online mode. So the offline mode is actually being used in the training process. So you're welcome to explore that and see how the performance of 3D GUT can actually increase using the DFix inside of the training process. Now, after covering the introduction, I would like to hand it over to Dee to discuss the proprietary pipeline that we have and how you can actually use the assets inside of Isaac Sim.
Thanks, Harold. Hi, everyone. This is Dee. So yeah, let's jump right into it. So we want to introduce you this NuRec workflow. This is going to be a release as a tutorial later on in October, hopefully. So we start essentially from a raw spec recording, right? This raw spec recording can be from any particular vehicles or any platform, AMR, humanoid robots, or just essentially maybe a handheld camera recording. From there, you can do, we basically do depth estimation, like foundation stereo or any other depth estimation that works well for your sensor. We also have a module called QSFM, which is a CUDA-like structure for motion pipeline that works similarly like a call map, which produces image pulses. We also can run image segmentations that can be segment anything or any image segmentation models like that. From there, we basically reconstruct meshes from depths and the pulses. Using NV blocks, we'd be able to get very good mesh. We have a point cloud fuser that produces the point cloud. We send everything into a module called encode converter that converts all the input data into a format that can be used by our NuRec engine. This NuRec engines work similarly like the released public repo 3D GRUT, which contains the variation of the 3D GUT plus the 3D GRT. GUT stands for unscented transform. GRT stands for ray tracing. So you can basically pick whichever variation you want to use. Usually we found that 3D GUT works better. From there, you generate a USDZ file. This USDZ file you can load into Isaac Sim and it will just be like a regular USD file, and then you can do visualization in Isaac Sim. So let's see some example. Yeah, so we released 3 assets from our pipeline. This is the real image view, training view, and lower view. Harry, you can keep playing. You'll be able to see that the reconstruction looks really good. If you see the lower view, it looks slightly different from the training view. We added offsets of 20 centimeters in the trajectory. So that just demonstrating that even if you shifts from your training trajectory, you still be able to do pretty good rendering. Let's go to the next slide. This shows the point cloud quality and the mesh. This shows the mesh quality. This mesh is created from NV blocks using foundation stereo depths plus our QSFM pulses. On the right side, you see the mesh rendered as a depth image in Isaac Sim. Yeah, let's go to next. This is the point cloud quality from our point cloud fuser. You'll be able to see the this reconstruction looks pretty good on the point cloud side of things. And the point cloud is then being used for initialization of the 3D GUT training. Yep, let's go to next slide. So yeah, so this is a view of us driving a virtual carter robot in the scene we created, and you see how it looks. So the same carter is interacting with the ground of the mesh, and you'll be able to drive it as if you're driving like a real robot. Yeah, that looks pretty cool. Let's go to next. So obviously we could also do this, NuRec Sim plus Sim-ready assets mixed and composed rendering. You see, we basically pop up those Sim-ready assets into the scene, and you can add whatever object you want. If you have a human, you can also add a human walking inside the scene as well. This gives us opportunity to essentially generate various of different test cases you would wish you would want to generate for your real world ODDs. Let's go to next.
So quick question here, D. We can bring in the scene through NuRec, right? Like we've brought it into Isaac Sim in USD form, and now you can have like the scene rendered over here. What you also mentioned was an interesting thing that you can also add in like assets which you already have. So sim ready assets, or maybe you've bought in your own assets through CAD converters, or however, basically you just converted them to USD. It is straightforward to add them into the scene. So that's like a mixed rendering sort of a setup where the NuRec scene comes through a different workflow itself, and you can still bring in other assets which could come in from different workflows, which can be then simulated together. Correct?
Yeah, exactly. So this will show also better how we did that if you play the video. So you'll be able to essentially just open the USD zip file as if you open a regular USD. And then you'll take some time to know because the Gaussians are large. So maybe Harold, if you can help skip a few seconds ahead. Yeah, so once you load it, right, you can then you can go around and rotate your camera and play with it, right? And then you can turn on the physics for the mesh, right? That's what we'll do here. We're turning on the physics. We set in the physics collider, right? And now you can essentially insert any objects you want. For example, we downloaded some mod from our public physical AI datasets. Those are sim-ready assets, right? Right. They have the right mass and mesh, and you can also turn on the collider, right? That's what we did. And then you hit simulation, and then boom, it drops to the table. So the table is created from our mesh, right? The table is the real world table, and the mod is a sim-ready assets. And then we can also see some other examples. Yeah, so we just added a bin, and you can change your location of the bin. And yeah, you drag it and drop. Yeah. So yeah, every time you need to add this collider presets so you can collide with other mesh. Okay, so yeah, we're just adding more mud. Thanks, Samir, for generating this nice video. It looks very interesting. As you can probably see that, see, that's the collision happens where you can, move object around and then they collide to each other. Yeah. Okay. So yeah, so that's pretty much everything on the simulation side of things. So you can see the sim-ready assets are still quite stand out from the background, right? Because we haven't really add any lighting to the environment yet. That's something we will like to do in the following quarters, where we try to figure out automatically, hopefully, that the environment lights of the scene and then the sim-ready assets, they will look much more realistic. This also enables us, to do local manipulation, humanoid robot training, where you want to train robot moving object around. Yeah, so let's go to our use cases. I think that's the last slide for me. And
Yep, we
yeah,
have a few questions though. Can we get to a few of them? I think like they probably are relevant from the stuff already discussed here. So before we move on to the next section, let's
No, I
quickly
think it
pull up.
might be good now before we jump to
Yeah.
the use case.
Yep. Hi, Ocean. Thank you. So the question is that the quality of the input data and resulting mesh directly determines the fidelity of simulation, right? What are
yes.
the key bottlenecks you've identified in real-world data conversion for robotics, especially concerning noisy sensor data or incomplete point clouds?
Yeah, so I think the key bottlenecks in real world data capturing is motion blur is definitely one of the killer points for us, especially with those RGB stereo cameras. It's very easy, and global shutter camera, it's very easy to get motion blur. So we kind of mitigate that issue by reducing the rotating speed of the vehicle during data collection. Because we can always control how we collect data, right? So as long as we drive slower, the motion blur effect is less. There are also a bunch of other problems we encounter, including timestamp synchronization between cameras, calibration of the cameras, including intrinsics and extrinsics. Getting those things to work well is also very hard. But we have a pipeline now for pre-deployment calibration and checking, and that get us to be able to do very reliable data collection. Yeah, I hope that answers the question.
Makes sense, yeah. And I also remember like in the architecture diagram you had on the earlier slides where you talked about a little bit about like point clouds. Any recommendations or like guidance over there, like incomplete or complete point clouds? Like I'm guessing point clouds can be captured from like maybe stereo cameras, or it could be even through the LiDAR itself directly. So does it fit into the whole NuRec pipeline directly, or
Yeah. So
okay.
the NuRec pipeline does support LiDAR. It's slightly trickier with LiDAR because you do need to calibrate LiDAR to camera very carefully, and LiDAR you need to handle motion compensate very carefully because whenever the LiDAR is a spinning LiDAR at 10 hertz, right? If your vehicle drives, you need to compensate that motion so that the projection from LiDAR to camera is properly compensated. So that itself is a slightly harder problem to solve. But if you have the technology that be able to do pretty good LiDAR to camera projection, then feel free to give the LiDAR point cloud to NuRec, and that would also produce very nice assets. That's what we did in our NDAS AV pipeline.
Oh, okay.
Yeah.
That makes sense. Another question which we have is, thanks, Gopal. Besides training robotics models, what are some of the potential applications for these high-fidelity reconstructed assets? For example, could they be used for virtual reality or digital twin apps? I think
Yeah.
one line of answer for this is yes.
Exactly. So training model is one of the use cases we will demo. Some you will demo that, but there are a bunch of other use cases. For example, pre-flight check, right? Because it's a very big pain point for robotics company that they want to reconstruct their environment. Traditionally, what we do is we have artists that just measuring the environment and then assemble the digital twins manually. But with this approach, we basically have a digital twin in a way, right? We have the mesh, we be able to render images, and you can do pre-flight check, right? You can deploy your stack in Isaac Sim and test your robot in the assets itself to see whether the navigation model works, or maybe the interaction between the robot works, or if the robot can avoid dynamic obstacles. You could add a human walking in the scene and then test whether your vehicle can avoid the human in your assets. So that's one of the major use cases we would like to enable as well. There are also other use cases like reconstructing a clip of data where you previously had an accident of robot colliding into things, or you want to discover edge cases of your navigation, and you can reconstruct that clip of data and then test whether your fixes for your algorithm or your model will still work. So that's actually one of the major use cases in AV is, we collected those clip of data and we want to test whether we add them into our CI/CD pipeline, right? And we want to test whether our model and our algorithm still works.
Yeah. And to add to that, you can also imagine, on top of everything that they said, kind of like larger scale scenarios when we're talking about an entire warehouse or entire facility. You have stationary cameras, you reconstruct the environment. Now you can place the stationary cameras and then monitor the environment with this digital twin in the background continuously.
Makes sense. Thanks, Ariel. And I think also given that the key component of actually being able to bring the asset into Isaac Sim is USD. So digital twin applications are obviously like completely possible, because like you can bring them into kit-based applications as well, for example, as long as in the USD form. So you should be able to have like the digital twin setup from your end once you bring in the asset itself. And another thing is that maybe on the AR VR side as well, like I think Dee demonstrated like depth perception and all those components are also still enabled. So you could actually try out enabling the AR VR extension and seeing if you can like get a NuRec scene to work. I'm not sure if that's been done already. Like maybe Dee and Harel know better if a NuRec scene has been used with AR VR applications, but my guess is it should be possible.
Yeah, it's definitely possible. For VR AR applications right now, one of the major use cases for us is to collect data for humanoid robots. So
Makes sense.
yeah, so you can wear essentially a AVP goggles, and you can collect data for humanoid G1, especially for G1 GR1 trainings with GROOT models, GROOT 1.5 models. We were doing that. Yeah.
Makes sense. Yeah. We have a question about camera recommendations.
Yeah, so that's a very good question because it doesn't work for every camera. One of the camera we really recommend is stereo RGB cameras, especially like Z camera is pretty good. We also worked with a camera vendor called Leopard Imaging. They have pretty good cameras, including Hawk camera and Eagle cameras. So as long as it's stereo RGB camera, it works very well. The reason is because we recently published this foundation stereo depth estimation model that works really well on stereo RGB cameras. Yeah.
Makes sense. Thank you. We have another question regarding, can the collision properties be saved? So I think as long as you, it's as long as you have added the assets in and you modify physics or any other attributes, it's as simple to save as a regular Isaac Sim scene. So with modification, so that should not be a problem at all.
Exactly.
There is a rendering question. I'm not sure if we have the answer here, but we can try. How do we get transparent volumes when using the Ply conversions? When we use the two USDZ volumes, USDZ splats, we get a black overlay between two USDZ volumes. Is anyone here more familiar with this? I'm sorry, I don't think I know the answer to this. I can bring up the question again in case.
Yeah, we can bring up the question again, but I believe that this is currently a limitation that we have.
Okay. Okay.
So we're kind of limited to math objects. Yeah.
Yep. Sorry, Sirens. I think we'll have an answer for you in some time, but right now we're not sure. Looking ahead, how far are we from real-time reconstruction with this conceptual approach? I think this is maybe more a question about how long does it take to maybe train the model itself so that you can actually bring it inside like the scene itself. So any ideas or suggestions over there? I think that obviously depends on the size of the scene and many other parameters too.
Yeah, so real-time construction right now is not a there's no use case for real-time reconstruction for now, at least for us, because we don't have to do that, right? We can reconstruct and then we simulate. I can see there are use cases where if you developing like a VR app and you have user collecting data in their environment and they want to see the reconstruction right away, right? Real time is going to be a very hard problem to solve, and there are also a lot of research paper that does that, but to accomplish the same quality as what we can do in offline is going to be very hard. It's all boils down to a trade-off of quality versus time, right?
Makes sense. Thank you. I think like real time is like another problem in itself altogether. Like any guidelines or ideas in terms of like maybe for example the scenes which were showcased in the previous videos right here, like how long did it take maybe on what sort of a GPU setup to train the model needed over there so that you can bring it into USD. So any estimates there? I know we had a few questions regarding can we run this on a 3090 or a 5090. So any hardware specs in terms of how this workflow might look like from the GPU standpoint?
I think right now the biggest limitation is on memory. If your GPU has enough memory to support training your scene, then it should work, right? Like if the number of CUDA cores are smaller, then it just take longer to run. So yeah, we'll have to double check what the minimum GPU requirement for the 3DG RUT training is. But we have been using DGX to train internally. I think we did train also on a laptop GPU as well. We hadn't trained that previously, and that seems to work.
Okay.
Yeah.
I think that is helpful.
Yeah, it's also depending on how much of your data capture is, right?
Exactly, that's what I guess. Like it obviously would scale with the scene size as well, right? A small room versus a factory is obviously going to be different in terms of how much compute and even like bandwidth is going to be needed for training that same model on different data. What are the key computational challenges when scaling this workflow for massive data sets such as those from a large-scale factory or a city? Does the system handle variations in sensor types and calibration errors automatically? Sorry, I'm confused. No worries. That's a good question, I think.
Yeah, so scaling is definitely one area we would like to improve because we don't have any logic of handling tiling at this point. If we want to render, for example, reconstruct a big city, then you would need tiling. For factory, I think if we change the parameters carefully to reduce the maximum number of Gaussians, it may still work for factory scale, but it's also depending on hardware configurations, right? Eventually boils down to the number of memories you have on your GPU. So that's so scaling up in terms of the sizes of environment is an area we will need to improve.
Makes sense. Thanks, D. I think we did answer a lot of questions over here. We can move on to the next section of our presentation too.
Okay, great.
Yeah. So, sorry.
Please go ahead. Samir is going to talk about the practical use case, how we're doing more fine-tuning with those assets.
Yeah. So, hi everyone. My name is Samir, and I'll be talking about navigation model fine-tuning with these real-to-sim assets as one of the use cases for these real-to-sim assets. Next slide, please. So Compass fine-tuning. So first of all, what is Compass? So Compass is a comprehensive framework to generate cross-embodiment navigation policies, which are robust and can work well in dynamic environments. The source code and the paper for this is publicly available, and also a pre-trained Compass policy is available on Hugging Face to use. Then we have the robotic NuRec assets. These are the ones that we have reconstructed assets which we have reconstructed for indoor scenes, and which we will use for fine tuning the models. And these are the scenes where the robot is actually going to be deployed in. These USDs also come with high fidelity meshes. So these meshes are basically for setting the physics properties such as collision so that we can interact with the scene. The motivation and the expectation for this fine tuning process is that we would be able to fine tune the existing policy on a specific environment to adapt to the nuances or the specialities of those environment, and that would help us to reduce the gap or any differences between the simulated data and the real world. Next slide, please. Yeah, so this is how the workflow will go about. So first we will do real world data capturing in the scene or the environment or the warehouse that we want to deploy our robots in. Then we will feed this data into a real to sim pipeline, which would generate the dense reconstruction asset. Then we would have the simulation step. So this is a step where we would want to make any modifications or add any new asset or set some properties to the USD before using it in fine tuning. Some of these cases are like in indoor cases, we usually see some parts of the room which are not properly illuminated. So in those cases, we could add a light source in that. Another case is the ground mesh might not be as smooth as required. So in that case, we could also add a virtual ground, and then we can have the simulation work properly on it. So after doing all these things, we would have the final sim-ready asset, which we can use for model fine-tuning and testing. Once this is done, then we can use the fine-tuned policy and the robot and deploy it in the real world. Next slide, please. Yeah, so the fine-tuning environment setup. So this is how the fine-tuning environment looks like. So the left one is the reconstructed cage area asset. So this is one of the labs in NVIDIA, and we use this as the training ground. The second video is the mesh. So this mesh comes as part of the USD, and we set some properties of it like the collision so that the robot could interact with it and then learn from it. On the right hand side, the image shows the navigable space that is used in this fine tuning. So the compass policy is being instructed to use this space as the training space. So it will spawn the robot in this and then set some target goals, and then the robot could learn by interacting with the environment and navigating to the goal pose. Next slide, please. Okay, so here at the input, we have the NuRec assets, and then we also have this pre-trained compass policy. This pre-trained compass policy is also available on Hugging Face. So we just use that as the base policy and build on top of it. So we feed these two things to the compass framework, and the compass does its magic and does the fine tuning of the policy and generates a fine-tuned navigation policy, which we can finally deploy it on the robot. Next slide. So now the next step would be to do the evaluation of these policies. So on one hand, we have the existing pre-trained base policy, and then we have the fine-tuned navigation policy. So for setting up the evaluation framework, what we did is we took the same asset that we use for fine tuning, but we added some more complexities to it. So in this case, we added a forklift here. Why forklift is because forklift was one of the obstacles that was used in the base policy training. So the policy basically acknowledges this or identifies this as a valid obstacle that it has previously seen. So we evaluate this on 10 different cases, and in each of these we start the robot from one side of the forklift and the goal pose is on the other side. So the robot is forced to take that narrow path between the forklift and the pole in order to reach the goal pose. Next slide, please. Yeah, so these are the 10 cases where which was used with the pre-trained compass policy, and you can see that only one case was such that it was able to recognize and consider that narrow space as a valid navigable space and walk through it and reach the goal post, whereas the other 6 cases it just kept hovering around and it didn't take that narrow path and reach the goal post. There are also 3 cases where the robot falls down, but for these experiments we can disregard those as those can be fixed by having a more robust whole body control policy, and we would basically not let the robot fall down. Yeah, next slide, please. So why the base policy failed? So here are some probable reasons. So first of all, the path between the forklift and the pole is narrow, whereas the pre-trained policy might have taken a conservative approach when doing the training. So basically, when it encounters an obstacle, it might add some buffer to it and then take a path around it, just to be safe that it doesn't dash into it. But in this case, it has to squeeze through these 2 obstacles, so it doesn't have the luxury to add like a buffer space to it. Another thing is there are some markings on the ground, like there's this blue tapes and white and yellow boundary lines which it has never seen before. Also, there are some reflections on the ground, so the robot or the policy might get confused on whether these markings or reflections are something that it can step on and navigate through or not. Then there are also some other obstacles in this, like the pillar and the cage, and also there are some metal boxes which it has never seen before. So the purpose of fine tuning is to have a scene, like every scene and environment can have its own special qualities and nuances, and so the fine tuning process would adapt to those special cases and could perform better. Next slide, please. So this is the evaluation result with the fine-tuned policy. So these are the same 10 cases that we showed previously, and in this case 7 out of those 10 cases the robot was able to identify the small opening as a valid navigation space, and it could navigate through it and reach the goal pose. There were again 3 cases where the robot falls down, but as we discussed earlier, we can disregard those and with having a better whole body control policy. Next slide, please.
Yeah. I think that wraps up. Did you want to share anything else?
No, that's it. Thank you.
Yeah. So thanks, Samir. So one thing I would like to point out is that if we go to the previous slide, you see the rendering quality of those videos doesn't seem to be very good, right? The reason behind this is the data capturing was around the robot height. If you deviate too much from your data capture perspective because it never seen those view before, the 3D GS 3D GUT rendering does not handle that very well. So that's one of the limitation of the approach is in order to do a good reconstruction for your platform, it's better to only render views around your platform's height or your platform's perspective. For example, if you have a Carter ground vehicle, you do Carter ground vehicle height reconstruction and data capturing and reconstruction. And then during rendering, you also around that view perspective. That works very well. But if you do, say, using an AMR Carter robot to capture the environment, but you want to render a humanoid height of view perspective, that doesn't work very well. So that's why we also had this handheld data collection capture rig for humanoid projects, where we basically handhold the camera around to capture different various of views of the environment, such that the humanoid robot can, do simulation in the assets, and the views and the rendering quality looks much better in that way.
Makes sense, Dee. Thank you so much. And I think it just comes back to the point, right? Because like the entire workflow is dependent on the perspective from which images are being captured. So like an AMR or a humanoid or maybe a quadruped, all of them will have like a different perspective during the data acquisition process itself, which is going to also then have the consequence onto the USD stage itself being rendered that way, because that's how the model got trained. So that's a fair call out too. And thank you so much, Samir. I think we can take a few more questions if you guys are okay with that, or if you've got anything else to share or any guidance or anything, then now's the time.
Yeah, one thing that I would like to share before we go to questions, we were talking about large scale before. So one thing I would, people can look up is the FEDB framework. So with the FEDB is an efficient data structure to support large scale. And then the FEDB structure supports Gaussian planning, including a reference workflow to how to train Gaussian planning using this data structure. So that's really helpful if we're talking about even, city scale reconstruction.
Thank you. I think we have a question. I think we've got two similar questions. Let me bring them up. When will we infer everything in the scene as an asset in real time? So you can manipulate everything. I mean, a true digital twin. And we also have a similar question to this, I think, which is the output in any way editable, like cropping objects, animating, etc. I think what both of these questions are trying to ask in a way is that now that you've captured a scene through NuRec, like, do you have access to individual assets as well? So, for example, in old school scene composition, when we like bring in our assets from the SimReady side, like we bring in the room environment itself, we add a table, we add a chair, stuff like that. So is it straightforward to have that even for NuRec assets? Because I think it comes in as like a whole complete mesh, right? Can you like crop out separate meshes as well and have them interact with the scene? Any ideas, Dee? And
yeah, great question. There is a lot here. Do you want to start?
Yeah, so that's the direction we would like to move forward as well. The only problem is that during the data capturing time, it's impossible to capture each individual objects for all various views. For example, if you have a box on the shelf, there's no way you can capture the back of the box. And that missing information during data capturing is basically making hard to reconstruct the objects. We had previously did a project where we basically surrounding a box on the ground, and then we'd be able to segment the Gaussians for the boxes out, and then we can add that boxes back to the scene, and that works pretty well, right? As long as you have data capturing of your objects, and in the end, you'll be able to segment the Gaussians belongs to the objects, then you can do this very well. So that's why we want to enable this composed rendering approach as a solution, right? Because even if you did reconstruct the 3D Gaussians for the object, still there's no physics property for the object, and enabling physics for 3D Gaussian is also a very active research area that people are working on. So I think it's possible in the end, in future, we can have 3D Gaussian to fully being interactable, and we may be enabling models like diffusion to help fill in the gaps of missing informations of data capturing for objects. So those are very active research areas. I think it's promising to move to that direction.
Yeah, exactly. There is a lot into it. It also depends on the different use cases and how you approach that. So absolutely, for manipulation, we kind of need this, fine physical properties. So the common approach right now is going to be generating the entire environment as a background with collision meshes, and then putting synthetic object with those fine properties on top of it from synthetic objects, right? And those synthetic objects can be taken from this sim-ready assets, the sim-ready warehouse, or through generative approaches in the future. So that's like one way to go. We're also introduced some libraries around specific asset generation. For example, bundle SDF. So with bundle SDF, you can capture an asset through camera and generate a pretty good mesh. And you can load that later into Isaac Sim and use that in your manipulation. And then we have all of the approaches around, segmenting Gaussian, taking out a specific area for a specific asset, and then replacing with another asset that can be synthetic or Gaussians. And then on top of that, there is a whole bunch of work. We're going to introduce a lot of that around like physical Gaussians. Few papers are going to come out, and few libraries that we're really looking forward to introduce, talking about accurate physics from Gaussians.
Makes sense. Thanks so much, Adil. I think like even the first thing which did come to my mind is like if in any way we could segment out the objects of interest in the Gaussian splat itself, like that certainly would give us some sort of an ability to maybe handle the mesh separately. But it's good to know like that there are other ways too, and I think like coming back to it, that's still an active area of research. So guessing like once there is progress made there, it's certainly going to come downstream into NuRec too. So
exactly.
Yep.
So it's about extracting objects and then pretty much fixing the hole that the extraction caused.
Makes sense.
Yeah, I saw a lot of chat asking about physics. How is our physics for the NuRec SX being constructed?
Yeah, sure. I can bring that question up.
Yeah.
I saw it too.
Mm-hmm. So eventually, it all boils down to the mesh we created, right? The physics of the collision all comes from the mesh. As long as we be able to reconstruct good mesh, you can do collision detection. Obviously, there's no other properties like, for example, mass and stuff like that. Those are not populated in those mesh. But we from what we have seen that at least the ground is very good. You can actually drive a AMR robot on the ground. If the ground gets bumpy or missing holes, you could actually add a virtual ground to your assets and have the robot interact with the virtual ground. Same applies to the tables as well, right? There are also questions, I guess, about
there is a question about can we drop in well-defined dynamic objects assets into the scan digital twin, and it's very similar to, let me look for the other one right here.
Yeah.
Thoughts
So
about capturing dynamic objects in the scene.
Yeah, those are something we can definitely do in Isaac Sim already, where you can just plug in your virtual human or virtual robot working in the scene, as long as the scene has good mesh and ground to be interacted with.
Right. I think it was very similar to what you showcased in your videos as well, right? In the presentation, when we had like the Nova Carter moving around in the scene, and you could also add another object. So apart from like one Nova Carter, you could be having, for example, a different moving forklift or other dynamic objects in the scene. Like it should not be a problem at all to get them inside that same NuRec scene.
Exactly.
I
Or a
think we
human
actually
agent.
answered, yeah, we answered a lot of the questions over here. So we seem to be in good shape. So. Maybe I can pass it over to the team if there are any other things they want to cover, or we can have Edmar come back in and have the closing remarks for us.
I know you guys got something you wanna say. Look, the way I think about this closing moment for you guys covered a lot of ground here. An amazing presentation, each of you, fantastic, really compelling, as you can see from all the great comments and questions that came in throughout, just all around. But if you're going to leave one piece of information to people who watch this office hours, this is your opportunity to say, what do you want to leave them with for sure? So let's do a quick round of that. Unless you want a couple minutes to think about it and go over some news and circle back to you. I'll leave it up to you, Rishab.
I'm going to leave it up to the team, I guess. Like I know what the title of the office hours itself is pretty indicative about like what the main thing is over here. So yeah, any pointers or most important things you guys feel we should keep in mind? I think like we're all ears.
Yeah. You know, one thing that I would like to point out that this whole field is moving so fast and so many interesting things are coming up. So just stay tuned because there is a lot more to come. Yeah.
That's awesome. Well said. Well said. Any other developers have anything you want to add? D, I know you got your finger on that button, D.
Yeah. So I think the message for me is, I have been thinking about this for a long time. Is we all want to create digital twins for our own environments, right? Like I want to create a digital twin for my home, and then hopefully I can train some robot to do stuff for me, right? And that's the vision of any robotics company that um, but how do you do that, right? It's very hard to actually create digital twin nowadays, and you need to spend a lot of time to do it. I think this technology really enables that. Although right now not everything are interactable, right? We can't segment object yet, but this whole field is moving towards that direction. So I think this really make this digital twin or sim driven approach of testing, data collection, model training really becomes a reality. And I think, yeah, this is great. Like Harold said, stay tuned, and I think this field is going to be great.
That's great closing remarks from D. Okay, unless Samir or Harold, do you guys have any other comments you want to make, or any quick takeaways? All right, I think you. Oh, go ahead, Samir. Go ahead.
Oh no, I think they've covered everything for.
He did. Mic drop. Yes. Okay. Cool. Awesome.
Edmar, you didn't ask me.
Well, I thought I gave you that chance first. Go ahead.
Okay, I think I gave it. I think
get the last
yeah.
word.
Oh no, you get the last word for sure. But just my 2 cents on it is that we already have so much already out there today in terms of like Hugging Face data sets, GitHub repositories to get started, and bringing in like existing assets in. So strongly suggest take a look at that. And like the others mentioned, that it's a pretty fast-paced field right now. Things keep changing, and advanced workflows will also probably be coming in soon. So getting on the board right now, getting on the train right now is going to make a lot of sense, so that you sort of understand the pieces at a high level. And once workflows keep improving, you're going to be able to solve more problems too. So that's it.
That's it. Great words of wisdom from Rishab. I mean, and obviously these office hours are a great resource for developers. So Amelia, our producer, has been pasting links throughout. Big thank you to you, Amelia. I'm sure she posted our ad event calendar, which is where you can see when the next office hours are coming, in addition to other live streams and topics that may interest you. We've been covering a lot of robotics, obviously, lately. Also, our study groups are there, and we have an Isaac Sim and Isaac Lab study group that happens every Wednesday on our Discord server. And word on the street is that today they're going to be covering the Isaac Lab white paper, NuRec and Warp, thanks to Omniverse Ambassador Scott Dempsey. So that happens every Wednesday at 12:30 p.m. Pacific. So if you're watching this live, it's in about a half hour from now. everyone's always invited to that study group. It's just come hang out, talk about the topics that we've all love to discuss, talk about challenges, resources, and learn new things together. It's just a great opportunity. All right, I'm going to share my screen to go over a few announcements. But before I do, I want to thank our panelists here who did just an amazing job on today's live stream. Just fantastic. So thank you for spending all the time and preparing everything. As a community manager, I'm always very grateful when we have folks from the NVIDIA team and our partners come on and share their knowledge, because I know it's really impactful for the developers that are watching. Speaking of which, thank you all developers for watching, as you're actually a big part of this. Your questions, comments that we see in the community and you send to us are super helpful and help guide our priorities moving forward. So speaking of guiding priorities, if this live stream has been helpful to you and our live streams in general in these office hours, it would be super appreciated for you to go ahead and subscribe to the channel and like this live stream in particular. That really helps give our team good insight on if what we're doing is hitting the right mark. And of course, like I said, reach out to us if there's a topic you want to see covered. Okay, so I'm going to share my screen really quick to go over some announcements that our great colleague Samantha Young has put together for us. We are basically, there's a lot of things happening. We are basically today, let me see, so much stuff happening. Today, I just heard earlier this morning that GTC in DC, which is happening at the end of October, is nearly sold out for the conference pass. And that's no joke. So if you were planning on attending GTC DC at October 27th, 29th, and where the sessions were important to you, absolutely, you should register right now. The Expo Pass is a little different, and there's definitely availability on those. So you don't need to run out and get it right now. But if you are planning to go, I would also buy that too, because that will fill up as well eventually. But Session Pass, if you're putting it off for another day, I would say if you want to go to sessions, today's the day to do that. Okay, so this is a part of the live stream where we go over all the news and announcements. I encourage you to grab your cell phone, get ready to grab these QR codes. This is going to be basically, we're going to try to whip through these QR codes. So I'm not going to stay on each screen too long. So be ready to capture these codes. They'll bring you to the assets or the blogs right away. So first, NVIDIA accelerates robotics research and development with the new open models and simulation libraries. Go ahead and go to that QR code there. You can train a quadruped locomotion policy and simulate cloth manipulation with NVIDIA Isaac Lab in Newton. Obviously, this topic is very familiar to everyone here. Go ahead and hit the QR code for more. Streamline robot learning with whole body control and enhanced teleop in NVIDIA Isaac Lab 2.3. Super exciting work now available to everybody. Advancing robotics development with neural dynamics in Newton. This QR code will bring you directly to that webpage. 3 easy ways to supercharge your robotics development using OpenUSD. We have a fantastic learning path, which is free, self-paced courses for robotics. I highly recommend anyone interested to go ahead and take that learning path. It's been very impactful. We hear a lot of companies using that to train their staff as well. How to instantly render real-world scenes and interactive simulation. There you go. There's a QR code for that link. We would love to showcase if you're leveraging the physical AI data set we have on Hugging Face, we would love to include your work, a visual of your work in an upcoming event. So this may be a video that we're putting together. And I think it would be so amazing to include the work from the community. So if you are leveraging that data set that's on Hugging Face, maybe it's helped you do things faster, maybe it's removed a blocker for you, please share, let us know. Get to that QR code to reach out to us so that we can look at it to see if we can include it in upcoming promotional material. As I mentioned, GTC is coming up. Now, even though this is local to Washington area, and if you can travel there, amazing. I would love to see you there. I'll be there. We're going to have coffee. We're going to have meetups, lots of cool events happening, physical AI events. We have a WhatsApp group for people who are going on site, so you can help you there in terms of planning your time as efficiently as possible. But if you can't make it, I highly encourage everybody to go to this QR code, go to the GTC DC page, and make sure you add the keynote, which is happening October 28th, to your schedule. There's going to be some amazing information announced by Jensen and shared through the world through a live stream on October 28th. So absolutely add this to your calendar. Jensen never, ever fails to make these keynotes extremely compelling, informative, and I think just generally fun. So go ahead and put that on your calendar. The Physical AI and Robotics Day is locked in for NVIDIA GTC DC. So if you are going, here's information on all those sessions planned for that day. And I'm sure there's going to be a nice get together as part of that. And we also have industrial AI and manufacturing sessions happening at GTC DC. Computer vision video analytics sessions. If you're watching and that interests you, there's that QR code. If you miss any of these, don't worry. Just ping us on the Discord, and we'll share these. Physical AI workshop and trainings. So there you go. There's a QR code for that. Make sure if you want to go to this, you register. I know most of these have been sold out, so apparently this one's still available. Hopefully it is. Oh, and there's a white screen of life. So let me get that off. All right, I think that's it for those news announcements. A couple of other quick things. The Omniverse launcher we bid farewell today. Thank you very much for your long life. We have a very funny post on the Omniverse Discord server from one of our community members saying goodbye to the Omniverse launcher. Go ahead to the Discord server and check that post out if you want. It's in the general chit chat channel. But on a serious note, if you are leveraging the launcher and you need help, we have great resources. Go to our forum page where we have the announcements. If I can ask Amelia to post that link in there, we show you exactly what you need to do to be up and running with not any missed beats if you need help moving away from the launcher. The Nebius Robotics and Physical AI Rewards, you can submit to be part of this until October 20th. We talked about this on a few live streams ago in the announcements area. I'll put the link in the chat in just 1 second. Actually, let me do it right now so I don't forget. There's the link for the Nebius Physical AI Rewards. Again, you have until the 20th, so still some more time. You have a few weeks. I'm really excited about this last announcement I'm going to make. Revel and Lychee AI have been working very hard on an NVIDIA Isaac Sim hackathon. This is going to be an exciting live stream set for tomorrow at 9 a.m. Pacific. Special day, special time, a special live stream. We're going to be announcing the top 3 teams and the community pick for the winners. And as you may recall, when we talked about this live stream, this hackathon, which started about 2 weeks ago, there are over 100 teams from all over the world as part of this that participated. An amazing roundup of projects. Revel and team, Brian Walker and Murmur Bay and others from the Revel team have been super helpful in organizing this event. The judges have met yesterday for over 2 hours to look at all the submissions. I cannot wait. If you follow us follow me on LinkedIn, I definitely shared this yesterday where they did a nice little highlight reel. But tomorrow is where the actual winner announcements happen. I'll put the link to this live stream that's happening tomorrow in the chat. So if anyone wants to come, add to your calendar, I highly recommend it. It's going to be a very fun hour. And I hope everyone out there can tune in and watch and make sure there's not any special things I'm missing here. No, I think we're good. All right. I want to thank once again everyone watching, but most importantly, I want to thank our great presenters here for setting aside the time for a very busy day. We actually, a lot of the team is coming off a Coral right now where we've been announcing some great stuff. So really happy to have you guys hang out with us today for this compelling Robotics Office Hours. If you missed part of this live stream, guess what? You can watch it right now on YouTube. All our live streams and office hours are there. So just go to the live section to the NVIDIA Omniverse channel, and you could catch up on the stream. Watch it in slow motion, watch it sped up, however you like to digest your office hours. It's there for you to help you with your work. I hope to see everybody on our Discord server. If you have a problem, go to our forums for Isaac Sim, go to the GitHub page for Isaac Lab. We'll be happy to help you officially there. Otherwise, talk with other community members. Discord's a place to be. We also have a nice LinkedIn group that's focused on Omniverse. So go to the Omniverse LinkedIn group and request to join. Lots of cool stuff we announced there as well. That about does it. Until tomorrow, a live stream on the Isaac Hackathon winners. Thank you everybody for joining us today. I want to remind all our guests to kind of hang out for a few minutes after I hit the end button so we can get your great feeds uploaded to StreamYard. Thanks everybody. Have a great rest of the day.
Thank you. Thank you for having us.
Bye-bye.
Thank you.
Thank you.